Hi everyone, welcome to the class. So today we will do a very nice concept. We have already done open sets, closed sets, compact sets, bounded sets. Now today I want to extend the idea to different points in a set and outside a set and or on a set. Okay. So today we will be discussing the concept of interior point of a set. Number one. Second, boundary point of a set. And number three, exterior point of a set. Okay, so we are going to discuss these 3 points today. Now, if you look at the terminology, interior means something which is inside. Boundary means something which is on the edges or perimeter of something. Exterior means something which is outside. All right. So we will define it in a real analysis way. And how do we do that? So assume that S is a set. Okay. Let X belongs to S. Okay. And in fact, let's, okay, take X belonging to S, or even if you do not say X belongs to S, that will be fine. So it is called an interior point of S. It is called an interior point of S if there exists a neighborhood. If there exists a neighborhood of X, we can call that neighborhood as n epsilon X. I will explain the meaning of n epsilon X, which is strictly contained inside the set S. So when I say n epsilon X, we means if we are in one dimension, it is either a set with X at the center and X minus epsilon, X plus epsilon. So this is the interval X minus epsilon, X plus epsilon. This is a neighborhood of X. So if you see, this is X, this is X minus epsilon, this is X plus epsilon. So if you look at this particular set in one dimension, this particular open set is a neighborhood of X. पड़ोसी है X का. ठीक है? So I want this n epsilon X to be contained in the set S. And if we are in two dimension, so suppose this is my set S, this is my point X. So I should be able to create a ball that is a neighborhood of radius epsilon. So that is what is meant by n epsilon X in 2D. It is a circle whose center is at X and radius epsilon. So what we are trying to say, a particular point is interior point of a set if there is a neighborhood of that point which is strictly inside the set, strict subset of the set, proper subset of the set. Okay, so we don't want any intersection on the boundaries. We want proper subset. All right. So for example, if you look at the set, 1, 2, okay, is 1.5 an interior point? Is it an interior point? So if we look at this set, I have 1 which is not included, I have 2 which is not included, and 1.5 is here. So if I choose an epsilon to be 0.1, I can choose epsilon of my choice. So this is this particular 1.5 comma 1.6, this particular open interval, it is a neighborhood of 1.5, and this is strictly contained inside the interval 1 comma 2, and hence 1.5 is an interior point of 1 comma 2. So any element of an open interval inside the set except for the boundary points will be an interior point. That is a guarantee. Okay. Now, suppose somebody asks you in the same question, is 1 an interior point? Now, 1 is at the boundary. So no matter how small epsilon you choose, 1 minus epsilon will be here, 1 plus epsilon will be here. There will be some part outside the set. So you will say no, because for any epsilon positive, n epsilon x, that is the neighborhood of x with, the length epsilon, intersection, the, you know, uh, complement of 1, 2 is not empty. That is how you write. So if any neighborhood, if I take any neighborhood of 1 that will have an intersection with the complement of the set 1, 2, and therefore that's not possible that 1 is going to be an interior point. Okay, so here x is equal to 1. So 1 is not an interior point because I cannot find a neighborhood of 1 which is strictly inside 1 comma 2, the open interval 1 comma 2, and therefore it is not an interior point. So once again, what is an interior point? An interior point is a point such that there is a neighborhood of that point which is strictly inside the set. At least one neighborhood we want. If we are not able to find even one neighborhood, that means it is not an interior point. All right. Now, the next concept is the concept of boundary point. As the name suggests, it means something on the boundary. So for example, if I have an interval 1 comma 2, so we can say that 1 and 2 are boundary points. We can see that, and we are going to do it mathematically now. And suppose I have a circle in 2D. So every point on the circle should become a boundary point. Okay. And every point inside the circle, they should be interior points. So let us have definition of a boundary point. So let X be an element. Okay. And before that, let S be a set. Let X be an element. X is called boundary. X is called boundary point of S if n epsilon X intersection S is not empty and n epsilon X intersection S complement is not empty. That means the neighborhood will have an intersection with the set S as well as the set S complement. Okay. So if I have, for example, now let us look at again 1 comma 2. Now let us see, is 1 a boundary point? Is 1 a boundary point? So let us look at the neighborhood n epsilon 1, which is going to be 1 minus epsilon 1 plus epsilon. Okay. Now I'll make the set. So my set is open interval 1 comma 2. So this is 1, this is 2. And let me make this neighborhood. So this neighborhood is 1 minus epsilon, 1 plus epsilon. So my neighborhood and set has an intersection. You can see that. So this particular portion, this particular portion, 1, 1 plus epsilon, this is belonging to, or this is contained in n epsilon X intersection 1 comma 2. So therefore, the intersection of the neighborhood with the set is not empty. Okay. Also, you can see that there is a part which is outside the set. So this particular part, the green part, that is 1 minus epsilon 1. This also has an intersection with the complement of S. So what is S complement over here? Minus infinity to 1 union 2 to infinity. I will exclude everything from 1 to 2, 1 and 2 not included. and that is going to be my complement. Okay. So this particular 1 minus epsilon comma 1 interval, this has an intersection with the complement. Therefore, 1 is a boundary point. So if you want to show that something is on the boundary of the set, you have to show that there is a neighborhood, or you can choose any neighborhood of that particular element. Every neighborhood will have an intersection with the set S as well as an intersection with the complement of S. Okay. So then we say that it is a boundary. This was the second point. Now, the concept is of what is exterior point. So exterior point means something which is outside. So if you again look at this open interval 1 comma 2. So let's take a point 3 outside. So this is 1, this is 2, and this is 3. So when do you say this is an exterior point? It is very simple. So X is called an exterior point of S if n epsilon X is strictly contained in the complement of S. So basically, when I take any open interval containing 3, that is 3 minus epsilon, 3 plus epsilon, this should be strictly contained in the complement of 1, 2. That is what is meant by boundary point. So we have done 3 points: interior point, boundary point, and exterior point. And now I will take one example of a finite set and I will check whether some point is an interior point, boundary point, or exterior point. Let us see. Okay. So consider the set 1, 2, 3. Okay. Take any point. So let's choose 2. Question: is 2 an interior point? Okay. So let n epsilon 2 be a neighborhood of 2. That means n epsilon 2 will be of the type 2 minus epsilon, 2 plus epsilon. It is an interval. Is this contained in the set 1, 2, 3? The answer should be no. Because this is an interval and this is a finite set. An interval can never be contained in a finite set. An interval contains uncountably finite points, infinite points. So this is not an interior point. So in fact, every element of a finite set, every element of a finite set is not an interior point. That we can see. Okay. Now let us again look at this set 1, 2, 3. This time let me choose 3. Okay. Is 3 a boundary point? Is it a boundary point? Okay. So if let me choose a neighborhood of 3. So a neighborhood of 3 will look like 3 minus epsilon, 3 plus epsilon. If you look at the intersection with the set 1, 2, 3, this intersection will always contain 3 and therefore it is non-empty. So n epsilon 3 intersection this particular set S is non-empty. Now what is the complement of this set 1, 2, 3? This is, I go from minus infinity till 1, union 1 to 2, union 2 to 3, union 3 to infinity. So basically, I am excluding all these 3 points from the real line all the other elements are the part of the complement. So n epsilon 3 is nothing but 3 minus epsilon 3 plus epsilon. Okay. So definitely this n epsilon 3 intersection 1, 2, 3 complement is not empty. You can see that this is a neighborhood around 3. So I have in this particular interval 3 to infinity, we will have 3 to 3 plus epsilon here, and we will have 3 minus epsilon to 3 here. So we are having a lot of intersections of n epsilon 3 with this particular set. So 3's neighborhood has an intersection with the set 1 to 3, and 3's neighborhood also has an intersection with the complement of the set. And therefore, 3 is a boundary point. And in fact, all elements of a finite set are boundary points. Okay. So I hope with the end of today's lecture, you people are clear with the idea of an interior point, boundary point, and exterior point of a set. They are not very difficult to understand. They are just English words, and we are mathematically expressing the idea of an interior, boundary, and an exterior point. Thank you. See you again in the next class.